Well, thank you, Kim, and greetings, everybody, and thank you for your time for listening today. What I'd like to do is spend about 20 minutes now to talk through some of the modern storage requirements that are needed for to support a server virtualization project, and highlight the major requirements you need to be looking for when evaluating and choosing a storage system to ensure success for a virtualization project. Just before I start, I'd like to introduce myself. My name is Paul Haverfield, and I work for Hewlett-Packard in our Asia Pacific Storage Business Unit. And my role is that of Principal Technologist or Technical Evangelist to talk about and promote HP storage solutions and help customers differentiate our storage solutions from those of the competitors within the industry. Okay, why would I be opening up this presentation here with a picture of an Angry Birds game and some logos from some of the major software vendors in the industry? Well, as it turns out, I believe there's a lot in common. There's a lot of synergies between Angry Birds, which is a modern game on smartphones, and major application software like VMware and Windows Hyper-V and Citrix. And if you think about the hypervisor software environment here at the moment, hypervisor software really is an application. It is a major application, and I like to think of it as a killer app or a killer application. And this software, this application runs on top of the hardware, and then it creates a virtual machine environment within itself, virtual servers. Now, what's in common between Angry Birds and these software applications? Well, for you to have a good time and have a good experience with Angry Birds, you have to have a really good modern smartphone or tablet device to run it on. You can't run Angry Birds and have a good time on a 1980s or 1990s Nokia mobile phone. You need a nice modern iPhone or Android phone, etc. And as it turns out, HP believes that it's exactly the same with VMware and Hyper-V and Citrix. For you to have a really good experience with these server virtualization software applications, you need to have a very solid, very modern hardware foundation to support the virtualization software. So first of all, I'd like to just ask the question, how ready are you for virtualization? Virtualization, can have a lot of impacts in your environment, particularly the data center and in the management of your infrastructure, and as well as, in particular, in the storage foundation underneath your server infrastructure. So there's quite a few things you have to think about, operational issues around how you organize your team, your organization, for data center management and infrastructure management. Virtualization can introduce challenges in terms of complexity. It can make some problems much harder to solve than a traditional physically provisioned server environment. Virtualization adds another layer on top of hardware, so you have to be able to have really good management tools that provide very good transparent end-to-end mapping to map your virtual machine, your application through to the physical server via the hypervisor, and then through to the actual storage and the volumes in the storage that the actual virtual machines are mapped to. And then what we're going to focus on in this session for the next 20 minutes or so is what are the requirements of a storage system, what are the essential capabilities that a storage system must have for you to have a good successful outcome in your virtualization project. So HP observes through talking to our customers and talking to software vendors such as VMware and Microsoft that a lot of customers that deploy the hypervisor software on top of legacy storage, they soon find that the legacy storage becomes the bottleneck, or it becomes the weakest link within their foundation. And what they find is they have some of their customers, some of their users end up being constrained, okay? So, we have group of customers here that wants to grow their hypervisor cluster, but they can't because they don't get any more performance when they add virtual machines, and then the other virtual machines slow down. We have another group of customers, or tenants we like to call them. They have to control the time of the day they do their backups. They can't do the backups when they choose to. And the other group of tenants here on the left, our SAP or our Oracle ERP application users, they can't do the business intelligence and the data warehouse reporting that they would like to, because it puts too much of a stress and a strain on the legacy storage system. So this is what we observed with customer environments that deployed virtualization on legacy storage, which was most of the time invented and designed around 20 years ago, which is way before the first internet browser was actually invented. So HP's premier primary storage system, 3PAR, it was a storage platform that was absolutely designed from the beginning to address the requirements of a very modern, very busy, very large virtualization environment. So when the gentleman that started 3PAR in the early 2000s, when they designed the 3PAR architecture, that was in the early days of virtualization, and they foresee the situation where you would have a lot of tenants, a lot of customers sharing a storage array. You have extreme aggregation and extreme consolidation in a virtualization environment. So in a typical 3PAR environment, underneath VMware, for example, we can support a lot of tenants that can all cohabitate happily. They all get along with each other. There's nobody arguing, nobody fighting with each other. And all of the different tenants can run their workloads, can run their applications to suit the business requirements and suit the application requirements without any compromise or trade-offs like what we saw in the previous slide. So let's just have a quick look before we get into some technical details. Why do you deploy virtualization in the first place? What are your primary success factors? Well, virtualization is all about three things, okay? You want a more agile or a more flexible application environment. You want an environment that's quicker to deploy applications, quicker to provision the resources for applications. You want an environment that actually reduces operational costs and capital costs. So you want to be able to do more with less. This means being able to run your resources, your servers and your storage at very high utilization, 80 or 90% utilization, so you get the most out of your investment. And then lastly, business risk. Every customer, every business, one of the CIO's primary objectives is to reduce business risk. It's just something they want to do. It's what's on their mind every day. They want to simplify DR, which is something the virtualization is fantastic on. And they want to be able to increase their availability. At the same time, they want to be able to modify their infrastructure, change their applications, deploy new ones without creating any more risk. So we'll just keep these factors in mind as we go through this and review some of the ways that storage can impact on a virtualization environment. So earlier on in this session, Kim talked about a virtualization maturity model, and it was a very good way at reviewing the different stages that a customer is at from when they first commence virtualization, through to like the first year, the second year, the third year, up until the point when they're, reaching a point of like 90% virtualized or 99% virtualized, and they've been having many, many years experience of virtualization. So what we notice, and one of the major aspects here that indicates how mature you are in your virtualization environment, is what we call the virtual machine density, which is how many virtual machines per physical machine you're actually running and supporting in your environment. Now, if we remember back to the previous slide where I talked about some of the metrics for virtualization success, virtualization at its heart is a financially driven initiative within most organisations. We don't just embark upon virtualisation because it's cool, because it has nice new software, keeps us all in our jobs. We typically embark on virtualisation to save money, to improve the return on investment on our infrastructure. Now, the primary method that we return a greater ROI or return on investment is by increasing our virtual machine density. And typically, as we move through this maturity model on our virtualization journey, our virtual machine density will increase as we go through testing and development and production, DR, up until large-scale multi-tenancy and possibly private cloud computing. Our virtual machine density will continue to increase. So HP does a lot of work with VMware. We're very close partners with VMware, and particularly in the storage aspects of VMware. We're always talking to VMware and working with their developers. And earlier this year, one of VMware's vice presidents of their storage area noticed and flagged to us that it was VMware's observation that a lot of their customers were having problems with bottlenecks in that they couldn't grow their VM density, couldn't grow their workloads, even though they believed they had free CPU resource and free memory resource in their VMware clusters. And what VMware found was that they saw in these situations that it was actually the legacy storage that was holding back the capabilities. It was a bottleneck for the overall performance or throughput of the VMware cluster. And what they find, what they determined in their analysis here, is that the impact of consolidating multiple applications within a hypervisor environment, it ends up delivering a very random I/O pattern out through to the actual storage array. And this very random, very diverse I/O pattern is something that legacy storage arrays were not designed to handle. And that in there created the problem that creates the bottleneck, and it impacts on actually limiting the amount of growth and the amount of utilization you can get from your server, virtual server farm. Okay, so why is it that legacy storage creates these bottlenecks, and why is it legacy storage is failing the virtualized workload environment? So if we have a look at the left-hand side of the slide here, you'll see that the traditional dual controller legacy storage array, it has three major bottlenecks, three major choke points. These typically are the dual controllers in themselves. The dual controllers can't scale as the capacity scales on the storage array, so the controllers themselves become a bottleneck. The disks on the storage array become a bottleneck because they're typically configured into micromanaged static RAID sets where the performance is limited by the way that we had to configure those static RAID sets when we planned the array initially. And the array and the dual controllers are typically connected by some kind of interconnect, and that in itself can become a performance bottleneck as well. So, the legacy storage architecture that we see on the left, it's very unbalanced. It's typically designed to grow in one direction only, and that's in gigabytes of capacity. It's not designed to grow in terms of capacity of performance of IOPS per second and megabytes per second. Now, if we have a look on the right-hand side of the slide, you'll see what we call a modern scale-out storage cluster architecture. Now, this is the clustered architecture that's used within the 3PAR storage platform, and it's the type of architecture required to underpin a virtualized server platform. So what we have here in this 3PAR clustered storage architecture, we have a very balanced environment of storage nodes which connect to back-end disk drives, and all of the storage nodes have their own CPU, their own multiple core, multi-core, multi-CPUs, their own memory for cache, their own host ports, and their own disk drives that they connect to. And in this cluster, all of the nodes are connected to each other. Okay, so they're all balanced, all connected to each other in a very balanced scale-out architecture. So this comparison here between legacy storage and modern scale-out storage, we can look at the comparison here with trains just to make this clear. On the left we have a freight train, a very old freight train that has 2 locomotives and it hauls behind it a lot of freight cars. On the right we have a very high-speed bullet train, one of the Chinese high-speed bullet trains. And the differences between these 2 trains typify the differences that we see between the legacy storage array and a 3-PAR storage array. So what is it about the 3-PAR technology that makes it so well suited to virtualization? Well, the 3 primary technologies here within 3-PAR that make it well suited to a virtualization environment is the system-wide striping, where we stripe all of your VM data stores across every single disk drive within the 3-PAR array. And we do this autonomically. It's not something that you have to spend a lot of time to configure or micromanage or plan in advance. It's just the way the product works that does it for you. The Mesh Active Controller design, this refers to the architecture we looked at on the previous slide. Now, not only is the data store striped across all of the actual disk drives, but the actual data stores are striped across all of the nodes within the array. Okay, so this is what we call a true active-active array. So any one data store on one volume can be accessed through every node within the cluster. So every node within the cluster can actually deliver performance and deliver IOPS against that data store's volume. So we call this complete striping. It's not just data striping, it's performance striping across the nodes in the cluster. And then finally, 3-PAR is the absolute premier array in the industry at managing multiple workloads, mixed workloads. So we can manage both small and large workloads in parallel without any compromise. And we'll have a look at this in detail on the next slide. So if we take a look here at this graphic, we can see a mixture of large block workloads at the top and small block workloads at the bottom. And what happens when they hit the host interface on our legacy storage array is that they get queued up behind each other. Now this has the exact same effect as what happens on the highway if you get stuck behind a truck. You have to wait. If there's no overtaking lane, you can't get around that truck, and the high-speed sports cars there slow down to the speed of the truck. What you really want in this environment where you've got large block workloads and small block workloads is you want the ability for them to be processed independently inside the array. You want an environment very similar to a multi-lane freeway. So if you come across a truck, you don't get stuck behind it. You don't have to queue up behind the truck. You have your own lane that you can be processed in, your own lane, you can overtake the truck, and you don't slow down to the lowest common denominator, which is the speed of the truck. So this is what we call mixed workload support within the 3-PAR array, and it's something unique to the 3-PAR array. We actually implement this within our ASIC, our silicon chip, which is the brains of 3-PAR, and this is something that no other storage array can do as efficiently as 3-PAR does it. So let's now just have a look at some of the software efficiencies that 3-PAR offers that, go back to delivering capability against our metrics for why we embark on virtualization in the first place, which is to reduce capital costs and reduce operational costs. So 3-PAR's thin provisioning technology is the absolute supreme, it's the premier implementation of thin technologies within the industry. 3-PAR was actually the first company to deliver thin technologies in the open systems marketplace, and the thin technologies in 3-PAR were actually built into the array. They weren't added on afterwards. Next we have the what we call the sub-1 tiering, or the adaptive optimization features of 3-PAR. This allows us to let you configure, say, 5% solid state or flash storage, and some fiber channel storage, and then the bulk of your capacity in cheaper bulk nearline storage. And the storage array just automatically knows which data is hot, which data is warm, and which data is cold, and it places the hot data on the flash tier, the warm data on the fibre channel tier, and the cold data on the nearline tier. And this is not something that you have to manage or monitor. It's just something that happens automatically, and it's done by the array, and it adapts to the changes in your workload as well. So there's no changes required once it's set up. And then these two technologies, they contribute to green power savings. Green savings in terms of reduced power and cooling, as well as reduced footprint in your actual data center. So we'll just take a look at very quickly now at the thin technologies. It's not all about just thin provisioning and starting thin. Almost any vendor can start thin. They can give you thin provisioning to begin with, but they have a lot of caveats, they have a lot of disclaimers, and they have recommendations to not use it in this situation, don't use it in that situation. With 3PAR, we have no such caveats, no such disclaimers. You can use our thin provisioning everywhere, and you can use it without any performance penalty, without any performance concern. It just works, and it runs in the background, and you won't even notice it. But it's not about just starting thin. You need to be able to get thin. You need to be able to convert existing volumes which are fat. You need to be able to convert them into thin volumes to reclaim space. In actual fact, we're so confident about the capabilities of thin conversion that we have commercial guarantees around the fact that we can halve the storage requirements that you need on a 3PAR array compared to a legacy storage array, and we can do that with a commercial guarantee. So then once you've started thin and you've got thin, it's very important to be able to stay thin, particularly in a VMware and a virtualization environment. You're always creating virtual machines and deleting virtual machines, and this means that you're creating space, allocating space, and then deleting it. It's very important that the array has the ability to reclaim that space and hand the space back to the storage array for it to be reused by further volumes in the future. So these are the three core technologies that make up the HP 3PAR thin technology suite. So what we're looking at here then is just some actual real dollar savings seen by a long-time 3PAR customer in North America. This customer has multiple data centers. They've got 1, 2, 3, 4, 5 data centers. They've got multiple storage arrays within each data center. And if we compare, the exported capacity, which is the 3PAR capacity presented to the servers, and compare that to the written capacity, which is the actual amount of data that they wrote, then you can see the savings here over these data centers of some 3.8 petabytes. That's 3.8 petabytes this customer did not have to purchase because of the efficiency of HP 3PAR's thin provisioning. And this adds up to a considerable amount of money when it's factored into the 3 years or 5 years ownership of a 3PAR array. And then, lastly, the major feature is autonomic. How easy is the storage array to manage? How much work do you have to put in to manage the storage array on a day-to-day basis? Many storage arrays require for you to go through a big planning process, a big process to map out your storage, plan your storage design, plan your LUN design, your meta LUNs, your hyper LUNs, etc. And then you have to track that in a spreadsheet, and typically what I see is a lot of customers they run out of colors within their spreadsheet, and it becomes very complex to manage and to track. So what you want is a storage array that you can just configure LUNs without making decisions, and you get it right, And if you don't get it right exactly in terms of your RAID level, then you have the ability to change the RAID level dynamically on the fly without any disruption to your host servers, to your host applications. So the array has to have the ability to respond to the unpredictable needs of a virtualization environment. And it needs to be able to maintain service levels, and not only maintain service levels, but guarantee the service levels through quality of service. And these are three areas that what we call the autonomic features of the 3PAR technology. So HP commissioned Forrester, which is storage analyst, storage consultant, to conduct a study of some 3PAR customers of ours. And what they found in terms of the total cost of ownership or the total economic impact, what they found was that these customers had tremendous return on investment savings. And then what they did, Forrester, they modelled these customers and presented and created a typical average storage customer and modelled the savings from 4 real customers into a model customer, and found that the ROI was typically less than 12 months, which is a tremendous payback and a tremendous return on investment on using 3-pass storage within a virtualization environment. So if we just go back to the beginning here, and if we recap, what is it that we are doing? Are we ready for virtualization? Are we actually ready to implement virtualization in our data center? Are we ready for the challenges that it creates for our management environment? Is our legacy storage up to the capabilities imposed on it by a virtualization environment? These are the things that you really need to consider when you start to plan a virtualization project. And the key point I'd like to leave you with is that some of us sometimes think, our storage is good enough. It's okay today. It can do the job. I'm happy with it. Well, the fact is, in modern virtualization environments, good enough is no longer good enough. Good enough today is almost guaranteed to not be good enough tomorrow, and it definitely won't be good enough next week or next month or in 1 year's, 2 years' time. What you need is a storage architecture designed for virtualization where the actual features were designed for Tier 1 enterprise computing, Tier 1 IT as a service, virtualization and cloud, and then those features have been migrated down in a common architecture and a common software framework to the mid-range space, which is the absolute sweet spot here for virtualization. Recently, HP just introduced 2 new storage products, the StoreServe 7200 and StoreServe 7400, which are absolute perfect storage arrays for a virtualization project. Lastly now, I'd just like to close with a very brief message around HP's converged storage strategy. We have one modern storage architecture for primary storage, for virtualization, IT as a service, and cloud computing. That's based around our 3-pass storage array I've just introduced to you briefly. We have one data protection architecture we call HP Store Once. This is industry's leading deduplication solution, which is focused around restore and restore times, not just on backup performance. It's a common technology from mid-range to high-end for both 3-part and Store Once, and it allows you to achieve very high utilization ratios unheard of in the industry previously. We're so confident about this, we back it up with commercial guarantees around doubling your workloads and doubling your storage without doubling your storage. It's simple, efficient, and agile. So thank you for your time listening to this the webinar from Kim and myself, and we look forward to working with you in your future as you embark on your own virtualization projects. Thank you again. Bye now.